Welcome back, guys. This is the last day of the unit in terms of notes, and it's not really notes; it's just kind of more instruction. So if you're not in here, I would highly recommend uh, you following through this at your own pace. Um, but you can pause this video and read this. This is more of an explore type of thing. We're going to graph what's called rose curves and cardioids today, and you're going to start by going to Desmos, clicking on the wrench at the top right under grid. By default, the left graph will be selected, which is a rectangular plane, and you want to select the one on the right, which will be a circular plane. And then we're going to type in the equations one by one using R equals and spell out theta as you would see it written in the equation. And then you're going to roughly sketch each one and answer all the questions that go with it. So make sure you go in order. For this test, you won't have to graph these, but I will give you a graph of a rose curve and a cardioid, and you will have to tell me what the equation is. So I would pause this video and then come back to it if you need to. But basically, these are the two equations that it's going to look like. So we've talked about how to graph a like a polar equation that gives us a line, both vertically and horizontally, and a circle for a polar equation. And now we're going to look at these rose curves. So A is going to give us what you should have observed as you're going through these. The number in front of the sine or cosine gives you the length of the petals, and an odd B value gives the number of petals, an even value gives you half the number of petals. And a cosine graph will always have a petal on the x-axis, and a sine graph will never have a petal on the x-axis. So those are some patterns that you need to observe as you're going through these. For a cardioid, let's look at kind of the difference between these. They kind of look similar, except we don't have a B and we have a plus or minus in front of those. So that tells us that this is a cardioid. That looks like that weird heart or whatever. A is half the length. So the length of the cardioid is 2A. A is equal to the width. And cosine graph is symmetric to the x, cosine's x, and sine's symmetric to the y. If your cosine is positive, your cardioid is going to point right. If it's negative, it's going to point left. If it's a positive sign, it points up. And if it's a negative sign, it points down. And that's what you need to do. So you need to complete the rest of the worksheet attached with all this in the practice, and then finish your delta math.